Among the billions and billions of planets and moons in this galaxy, we may encounter many examples of double planets, but what would they be like and could life arise on them? When we think of planets out there in the cosmos, we usually envision solitary spheres orbiting a star, or perhaps one with a large moon or two like we do. Sometimes we envision not planets but large habitable moons around some even larger gas giant. But out there in the vastness of space, some planets have formed an extraordinary partnership, locked in a cosmic dance with another planet that eventually leads them to looking at each other's face all day, every day for billions of years to come. These are the double planets, a fascinating phenomena that raises even more questions about their formation, evolution, and unique conditions that might be present in them. Could we find where neither was a moon but both were large and habitable like Earth? And would life have evolved from one of those doubles and spread to the other? Could life continue to move back and forth between them? And would such life tend to adapt to natural space travel, able to move to other planets or asteroids in that system? We will discuss these and other ideas such as the Roche world, where two planets form a physical land bridge between each other. And if those sound like fun topics, make sure to hit those like, subscribe, and notification buttons. It is not too hard to imagine standing on the surface of one planet and gazing up the skies at a giant body, as we do with our moon. But what if that body was covered in oceans and green continents and white clouds? As much as the moon fascinates us, surely that living world being in the sky would grab our attention even more. But is it as big as the moon in the sky, or larger or smaller? Of course, this would depend on not just its size, but its distance, and thus seems hard to say. We can answer the question here and say a double planet could never be smaller in the sky than our current moon appears. Earth is 4 times wider than the moon, and a copy of Earth where the moon was would be 4 times wider to our eyes and 16 times bigger in width and height, and also 16 times brighter during a full moon. But it could be further away, rather than closer, except it would need to be 4 times further away, and that would take it to the very edge of Earth's hemisphere, the region where Earth gravity dominates over other bodies. Beyond here, the double planet would orbit the Sun instead, and just be a neighbor, and they would orbit with one a couple million miles or more closer or further from the Sun. That hemisphere, where you can stably orbit a place as a moon or partner, is also controlled by how close you are to a given star, and so is smaller in the habitable zones of red or orange dwarfs, where you could have larger neighboring planets like Jupiter perturbing your orbit. But what it means is that you wouldn't ever expect a double planet to be significantly smaller in the sky than our own moon. In the other direction, there's the Roche limit, at which gravity and tidal forces from your neighboring planet would begin ripping your own surface off, which we'll cover later. We will also cover the special case where the two planets are tidally locked and both still have a 24-hour day-night cycle, specifically a double Earth case, which we might imagine happened if someone accidentally opened up an inter-universe wormhole so that a copy of Earth from one multiverse fell into a neighboring one, so both Earths orbit each other. And we'll consider air bridges between such worlds, sea or land bridges between, or artificial ones like the Acheron River we discussed in Colonizing Pluto between that planet and its own relatively large moon. Arguably a case of double dwarf planets. We even discussed multi-body scenarios like several planets sharing an orbit, such as a Klemplerer Rosette. But let's begin by asking how such double planets could arise and what forces could bring them together and forever entwine their destinies. There's a few possible origins for double planets, and the simplest is that they formed from the same protoplanetary disk, just as planets usually do. Only as the clumps emerged, rather than all falling into one spot, we had 2 pair of clumps forming close enough to be in each other's hemisphere, but not quite close enough to merge. It would help if we knew for sure how all our own planets formed and got moons, but the default assumption is that there were way more planets in the early days of the solar system, and that many were tiny ones that fell into some other planet or the sun, or became moons, or were ejected from the solar system, or even just vaporized by the solar wind and radiation like happens to comets. 2 forming this close might not be too improbable, but in the highly unstable early solar system, it would be much easier to perturb them so they merged or broke apart. Alternatively, a capture, one planet capturing the other, or they each other, is also a possibility. It wouldn't be the most likely outcome of two neighboring planets being perturbed near each other, but in a galaxy of 1 trillion worlds, even if it were only 1 in 1,000,000, that would leave 1,000,000 double planets. Our current ability to model developing planetary systems is not good enough to let us speak to the probability of this with any accuracy, but I wouldn't think it was so rare as that. So too, we believe our moon formed from the wreckage after a dwarf planet slammed proto-Earth and ejected matter into space, some from each object, some lost the void forever, some falling back to the new Earth, and some forming our large moon. It would be entirely plausible that a high-energy impact of two other bodies, possibly one a super-Earth, could have jettisoned out enough material to form an entire second planet. Indeed, that debris disk might have been big enough to allow some further out to form another moon too, orbiting both new planets. As a side note, either planet could have a smaller moon close to it. That gives us 3 different pathways to a double planet, and none seeming very odd. There is a distinct unlikeliness you would have 2 of nearly the same size and both habitable, but that might merely mean that 1 in 100 systems has double planets, and 1 in 100 of those has a combination where both are half to double Earth's mass. There are no implications they would be exactly the same size or even close, and so one could argue we never get a double planet, as we just have one being a moon of the other, but this offers no concrete definition free from arbitrary cutoffs and categories. Many have sought to define double planets, and I would say the only necessary cutoff is that Earth and our moon should not be counted as such, given that it is the defining example of a moon. There's 3 real factors in play here worth considering. First, is either body worthy of the name planet in terms of its own raw mass? Second, is either just so much larger than the other so as to merit nothing more than being a moon, as Earth would be around Jupiter, or as even some ice giant like Neptune might be around a brown dwarf? And third, what's the distance between them and orbital mechanics? Isaac Asimov once suggested the definition for a double planet instead of a moon is when the barycenter of orbit was outside of the larger body. Moons don't really orbit planets, they all orbit a shared spot with their partner called a barycenter, but for most planet-moon systems we know of, that barycenter is inside the bigger planet, and often in its core rather than upper regions. But even these still wobble, and it's one way we detect exoplanets around other stars, or possible exomoons around exoplanets. We know where they should be, but they are just a hair off, and in a way that repeats, as that satellite orbits it and gravitationally yanks it back and forth a bit, and from that we can determine the mass and distance of the orbiting body. And I think if we had 2 large bodies, even of very different masses, that did orbit each other but at a great distance, they may still be sibling planets but no longer seem a pair of twins, maybe fraternal twins. In any event, no clear line seems drawable beyond what we have with Earth and the Moon, so we will not bother defining it further, and while the distance between them might seem the lesser factor of those 3, the others being their total size and relative size to each other, the distance between them is the biggest factor in other aspects of their relationship. Bodies which orbit each other slowly exchange angular momentum, until they reach a state of tidal locking in which first one then both bodies keep the same face pointing toward each other. The overwhelming dominant force in that tidal friction is the distance between both bodies, rising with the 5th power, so that an object twice as close will tidally lock 2 to the 5th or 32 times faster, while one 10 times further away will take 10 to the 5th or 100,000 times slower, all things being equal. If you've ever wondered how that happens, understand that 2 bodies are constantly exchanging vast amounts of gravitational energy with each other. It is huge, and the sorts of energies moving between Earth and the Moon over 1 month of orbit dwarf the energy the Sun shines upon us during that same period. And they are not point-like bodies moving in perfect circles. The Moon pulls on the side of the planet it is nearest harder than the far side, and more or less depending on if it's at its closest or furthest point of orbit from Earth. This distorts the planet, and a lot too. We're talking miles of change. Those bits stretched toward the Moon experience even more gravity. As the Moon and Earth orbit and rotate to move this spot, it's no longer directly facing the Moon, and some new places bulge out to take its place. That other area still takes time to sag back. While it's up, it's experiencing a stronger pull of gravity by being closer, and this doesn't balance with the other side just getting ready to be in the middle. So there is a slightly higher force on the side of the planet rotating away, and that force is back toward the middle. So this is a braking action, slowing the wheel until it stops rotating at a different speed than the other body orbits. And this is tidal locking, where the one body rotates at the same rate it orbits. This is why the moon always shows us more or less the same face, and why virtually every moon is tidally locked to its parent planet. Mass is a powerful secondary factor in this, so bigger planets cause faster locks to them, while also resisting a lock longer, hence why the moon is locked but Earth, being far bigger, is not. Not yet, anyway. Composition matters too, as oceans sag back down into place way faster than rock, and are less dense, thus have less mass to generate gravity, and both cause less tidal friction, same for atmospheres. We estimate our own moon, which was way closer at the time it formed, only took about 100 million years to tidally lock after forming. We estimate the Earth had a day only 12 hours long back then too, and it's been slowly getting longer, though the tidal force on Earth is diminishing as the moon creeps further away. Again, the tidal locking rate goes with the fifth power of distance. If we are assuming 2 habitable planets though, that time should be longer, and we would expect Earth to lock to the moon in about 50 billion more years, about 10 times as long as the sun has left before it burns Earth out. And while there are ways to prevent or delay that for even trillions of years, they all involve a scale and capability that permits you to unlock tidally locked planets too, so Earth will never likely get locked to our moon. But a planet half the distance and 80 times the mass of the moon, like Earth is going to lock roughly 200,000 times faster, as it goes with the fifth power of distance, but also the square of mass. And 50 billion divided by that is around 250,000 years. Though that's a very loose figure, and the equation for calculating tidal locking can generate some iffy numbers. For instance, Earth, by the basic equation, would have locked to the Sun already, and indeed I've seen this in arguments that Earth must be younger than we think. But the moon orbiting us messes with that, and so does having an atmosphere and oceans. Distance being a stronger factor than mass, I think if we had a double planet and no moon around either, which is also possible, we likely would have a tidally locked pair of planets long before life could arise and evolve the eyeballs to see their twin planet with. It would also appear huge in that sky, 8 times wider and 64 times more area reflecting sunlight at night, or 64 times brighter than our own full moon. Though as a reminder, our eyes are logarithmic in their light sensitivity, so we tend not to realize the sun at noon is hundreds of thousands of times brighter than a full moon is. So even this huge twin planet in the sky is not allowing plant growth by moonlight or leaving any doubt that it is nighttime. And the sun both planets shared would still illuminate all sides of both planets. Only planets tidally locked to a star have one side eternally lit and the other in total darkness. Also, regarding moons, much like planets around binary stars, it is possible for a binary planet to have a moon of its own, or for the pair to share a more distant moon orbiting both. Weird orbits like figure eights around both are unlikely to occur naturally or be stable, though I would bet civilizations on double planets would make a lot of spaceships and stations on stranger orbits like that. A loose rule of thumb is that a body can't have a stable satellite further away from it than a ninth the distance to whatever it orbits itself, and I would also say it would need to never get anywhere near as far away as the L1 Lagrange point of that body to its own parent. I would also guess that unless we had the big collision disk case from earlier, from which one planet formed and the outer part of the disk formed a moon around both, that we would only expect moons captured since the pair became doubles. I think any moon predating that coupling would probably have gotten ejected or collided with one of them. Now again, it is very unlikely we would have 2 double planets, even habitable ones, that both had roughly Earth mass and day length, but we would expect them to have the same day length as each other, not to mention year length, and then their total day length is based on their distance from each other. Orbital periods have to do with the mass of both objects, when they're in the same order of magnitude at least. So if you're guessing that a double planet's distance from Earth, in a double Earth case, would be geostationary height, you're in the right zone, but no. It would be a center-to-center distance of about 54,000 kilometers or 33,500 miles, or about 26,000 miles from facing surface to facing surface, while geostationary over Earth is 22,000 miles up. I will call these Earth 1 and Earth 2 and assume Earth 1 is the more massive of the pair, though for this example I'm treating them as near identical. Days get longer a lot faster as we draw these bodies apart. At twice the distance it's already 3.5 days. At the moon's distance it would be 19.5 days. So shorter than a month but much too long for a day. And again, the partner planet isn't giving a lot of moonlight or planet light at this distance. Though at the 24-hour distance it would be more than 100 times brighter than our own full moon. And interestingly, that means it's visible and impressive day and night, but only from the half of the planet that can see it. The other side never sees it, and the same for the other side of the twin planet, and neither gets any moonlight so has fairly dark nights. This is likely to hugely impact the biology of both planets, but the tidal forces are likely to be an even bigger impact. At this distance, about 7 times closer than the Earth-Moon system, and with 80 times the mass, your gravitational force between these worlds is 4,000 times stronger. That means when the planet whips around to the other side, the force yanking those tides back the other way are doing it 4,000 times more enthusiastically than our moon does. And while we don't really know what role the moon plays in our tectonics, we are comfortably certain it is a big one. So we should assume that double planet has a good deal more tectonic activity. Indeed, gravity on Earth 1 is going to be 1.4% lower on the side facing Earth 2 and vice versa, while the sides facing away from each other have 1.4% higher gravity. This makes me revise an opinion I gave on this topic when I covered it way back in Season 1 in a video about half our normal episode length, where I said I wouldn't expect any air bridge between these planets. An air bridge that actual animals can fly through between Earth 1 and Earth 2 still seems dubious, as our atmosphere is unbreathable just 30 miles up, not 30,000. However, we have a lot of factors that needed to be considered here and which cannot be accurately modeled yet. First, that whole double planet system has quite the combined magnetic field that's probably helping keep solar wind from stripping air off both planets. Second, all those tides, at a pretty extreme level, probably are surging air up even more than water. Third, there's a good chance this place has got some serious and steady volcanic activity going on that's spewing mass up into space. Enough that I would not be too surprised if there was a haze between the planets and even a thin fog up at their shared L1 Lagrange point. That makes it seem a lot more plausible that we would have some transference of microbes between planets, so that one seeded the other and that they occasionally seeded back and forth, which might have some weird effects like every couple million years you had an invasive species or extinction event as some wildly different but compatible microbes or spores fell down from the heavens. And the last 2 points, we know that extremophiles can adapt to some insane conditions if they can do it gradually, and we know that the reason Earth has so little hydrogen and helium is because of the long stripping process of our Sun, and these worlds might have attained more, and so organisms that successfully use molecular hydrogen or helium as a lifting gas could have evolved and gotten big. Some gas bag or space whale evolving to be able to move along that ultra-low density atmospheric column between those 2 planets is not unreasonable. And of course from there we can imagine other organisms learning to hitch rides on them. Maybe it uses oxygen as its equivalent of a ballast tank in some pocket or orifice a decent-sized critter could hop into. And given time, that truly does open the door to such creatures evolving further to wander their interplanetary void. Now we can eventually build a space elevator between these as a physical bridge, and we discussed that more with our Acheron River design between Pluto and its moon Charon, as here there is a steady straight line between surface to surface, and while they may be a bit eccentric as opposed to circular in orbit of each other, any elevator is likely to be able to handle some stretch and can always have winch elements adjusting the tether length and tension. They will need impressively strong material to build that elevator out of, same as us, but I think they would be a lot more willing to try projects like that, and something like the Apollo program as soon as they thought they could work. Given a bit more technology or active support systems, they could build a space tower right between those planets and run thousands of major transport lines down it. Indeed, you could use that to slowly stabilize their mutual orbits so as to never drift further or closer apart. Could a physical bridge form naturally between them? Well, surprisingly the answer is yes, and that brings us to a Roche world. If our planetary pair were slowly growing closer, a few things would happen. First, the day length would shorten, and when they were about 13,000 miles from surface to surface, that day period has dropped to 12 hours. That force between worlds shifting gravity rises from 1.4% to over 5%, and all that tectonic activity and tides and volcanic eruptions goes up too. That doesn't mean the planet is uninhabitable, and indeed this is how fast we think Earth was spinning back when life started. Whatever air bridge you have between worlds is now orders of magnitude thicker than it was, though it might still be much too thin to breathe, hard to say. As this distance contracts, that atmospheric column between worlds will get thicker, and at some point you would expect to reach the Roche limit. The Roche limit is as close as an object holding itself together by gravity can get to another large body before being shredded, as the larger body pours on the surface of the smaller one harder than the smaller one pours on that surface itself. Material starts coming off and ripping the smaller boards slowly to pieces. This gets worse from both the deformation from gravity and the centrifugal spin near the surface. However, while Earth might rip apart a small moon that came too close, this situation is different. Equal-sized or near-equal-sized bodies have much lower Roche limits, so close they practically have to be touching, but even our moon, if brought close to Earth, would still have to be within 6,000 miles, core to core, before the surface gravity on the moon reached zero on the spot closest to Earth, where Earth's gravity now poured as hard as the moon did. They would only be a little over 1,000 miles apart from closest point to closest point, and very easy to build a space elevator between them now, and an air bridge would seem guaranteed, maybe even a comfortably breathable one. Can this actually get to the point where they are touching? Yes, and not necessarily apocalyptically, at least not in the short term. On geological timelines, as the two planets merge, this is going to be devastating to the point of sterilization, but not necessarily when they touch. As they approach, they stop being spherical planets and get more egg-shaped, and then when they touch, you get a land bridge, but also a sea bridge over it, and presumably now can sail between these planets. Your day is now only 4 hours long, and on the backside of these planets there is going to be some centrifugal force, and if you smash the merging pair at this point, you could end up with a donut-shaped planet emoji instead. Over time, this bridge is going to thicken and shorten, and should always have seas and breathable air over it, with down pointing to the ground beneath you, though it's going to be on the weaker side. Your land and sea is always sliding to where gravity is strongest, so there won't be places without it or where gravity isn't perpendicular to the ground. With sufficient engineering, you could make something like this artificially and stably, and while I suspect there will be plenty of examples out in the cosmos of this process occurring naturally, I'd imagine intentional mergers, or actions to slow it down to keep it a tourist hotspot, would be common. Or maybe folks would try to detonate one to turn into a hoop planet, but I think the artificial Roche world, one connected at the 24-hour mark, and by some very large bridge megastructure, would be the more common approach to this. One last topic for contemplation is the idea of triple worlds, or quadruple worlds, or more, and this is where we get to the Klemplerer Rosette. There are quasi-stable orbital spots in any planet's orbit around its star, or moons around a planet, at the L3, L4, and L5 Lagrange points, which are respectively 180 degrees ahead and 60 degrees ahead and behind the orbiting body. But if we put two at the counter locations, each other's L3s, we could then add 4 more objects at their 2L4 and 2L5 spots. If they are all the same mass, or alternating mass, 3 of 2 different masses alternating every other spot, this is decently stable, and maintenance of it is well within the ability of any civilization who put them there to begin with. This is now a stable 6-body system, and you can see our megastructure series for discussion on how to build and move planets. You might make shells around a large gas giant planet of compressed gas as a way of storing fuel for your sun for down the road, and while having a planet 100 times larger than Earth to live on. You could do 6 or 8 or even hundreds, complete with an interlocking ring suspended above the north or south poles for super-fast transport between them and stabilization purposes. You can also do this with no central object, so you could have 6 large moons orbiting a bigger planet that's orbiting that sun, or leave that planet out, that would make it more prone to perturbation. One might imagine a civilization engaging in star lifting to mine its own sun, as we discussed in atmospheric mining, and extending its lifetime in the process, having 5 Saturn-mass planets in a Klemplerer Rosette around that sun, each storing tens of millions of years of fusion fuel, each with 100 giant continents on them, and each orbited by a dozen Earth-sized moons in another Klemplerer Rosette, for a total of 60 mega-Earths and 720 normal Earths, or 6,720 Earths worth of living area, and with over 1 billion years of fuel waiting inside them. If 2 planets are better than 1, surely more is even better. After all, the sky is the limit, unless you're on a Roche world, of course, in which case the sky is the rest of the planet. As we saw today, a double planet, or just one with a moon bigger or smaller than ours, would hugely impact how life emerged and evolved there. The process by which life arose and moved from that first basic cell to us nowadays is fascinating, as is contemplating that future out among the galaxy. If it fascinates you too, check out Cell to Singularity, a free-to-play science-based game that walks you up the evolutionary and tech trees from that first moment all the way through a technological singularity and settling neighboring worlds. Some of Cell to Singularity's developers are part of our audience, and so Cell to Singularity explores many concepts we discussed on this show before, and they share our belief that a story or game can be entertaining while being based on real science and research, so you can enjoy a wonderful sci-fi setting while playing a scientifically accurate game on a journey through space and time. Explore from early Earth out to among the stars in a game that fits easily into your busy day and again is free to play. Try it out on Steam or on your phone. Available on iOS and Google Play, and start building your civilization up from Cell to Singularity today. This weekend's livestream is cancelled, and instead we will air the bonus episode Space Hygiene on November 26th for a look at the dirtier aspects of space travel. Then on the 30th, we'll look at the dirtier aspects of space settlement with agri-wars and have a discussion about how you could farm an entire planet. Then we'll start December with a discussion of how to select spaceship crews, before returning to our Alien Civilization series with Nihilistic Aliens. Then we'll talk about ways to warp and manipulate reality on December 14th, before discussing silicon-based life forms on the 21st. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon, and if you want to donate and help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service, Nebula, along with hours of bonus content at go.nebula.tv/isaacarthur. As always, thanks for watching, and have a great week.